So again, I hope you are all fine, my dear students. Last week, we started in one session a new mathematics lecture in semester 2. And as you still remember, the title of our lesson was Thales Theorem. In this lesson, we are only going to study one thing, which is a theorem that can be applied in mathematical geometry problems. And it is somehow similar to the theorems that we studied before. We have studied 3 theorems before: the midpoint theorem, the median segment theorem, and Pythagoras theorem. This is a similar theorem in this lesson. So last week, I talked about Thales theorem. Thales theorem is applied in triangles and in any kind of triangles, no special kind of triangle. For example, if we have, Thales theorem can be applied in these 3 different positions. So we might apply it in the first figure or the second figure or the third figure. I will be talking about each figure apart, alone, and I will be asking you to answer questions while I'm discussing, because I have discussed this before. So if in the first figure we have a triangle ABC, I have taken a point M on line AB. I have taken a point. Good morning. Who's this?
Jad.
Hi, Jad. How are you? Fine?
Yes, miss.
Okay, we have just started, Jad, okay?
Okay.
So we have taken a point M on line AB, between AB, as you can see, and N is taken on line AC, between AC. And when we take the 2 points M and N, there is a condition. We should take ABM and ACN in the same order. What do we mean by the same order? If we take M between AB, also we should take N between AC. After taking the 2 points M and N, if the line MN is parallel to the line BC, I want here to ask Mariam. Can you answer me, Mariam?
Yes.
Okay. If Mariam,
Wait, miss, is this a new lesson?
No, who's this?
Amir.
No, Amir. We started this lesson last week, and I'm repeating what we said last week. How are you, Amir?
Okay.
Fine?
Yeah.
Yeah, we have just started, Amir. So if we have Mariam, the line MN and the line BC are parallel to each other's, which vertex is opposite to these 2 lines, Mariam? A, right? Yeah, it's vertex A. So now, if I wanted to apply Thales theorem in this figure, I can apply it. Why? Because MN is parallel to BC. So to be able to apply Thales theorem, we should have parallel lines. So we say, since line MN is parallel to line BC, then we can apply Thales theorem in this triangle. Whenever we need to apply Thales theorem, we should choose a vertex. Which vertex?
Hi, miss. Sorry I'm late.
Don't worry, Alex. Okay, continue with me, Alex. Don't worry. So we should choose a vertex to start writing the ratios of Thales theorem, because in Thales theorem we need to write ratios. Which vertex do I choose to start with? I choose the vertex opposite to the parallel lines. So because MN is parallel to BC, the opposite vertex is A. That's why, since A is the opposite vertex, who can apply Thales theorem in this triangle? Jad, can you apply Thales theorem in this triangle, please? Jad, are you still with us?
Yes.
Okay, please, Jad, apply Thales theorem in this triangle.
Okay, we start AM.
Yes.
Over AN.
No, Jad.
Oh, no, over AB.
Yes, so we start AM over AB is equal to what?
AN over AC.
Right, is equal to?
MN over BC.
Thank you, Jad. So this is how we apply Thales theorem in the first figure. Let us directly look at the second figure. Also in this figure, we have a triangle ABC. We have taken the 2 points M and N. But here, I have taken M outside AB. I have taken N outside AC. Because AB and M, AC and N should be in the same order. So here, if the line BC is parallel to line MN, can you tell me, Yasmina, who's the opposite vertex to BC and MN? Yasmina, which vertex is opposite to line BC and MN? Yasmina, are you still with me? Nurjan, can you answer me, please?
Yes, miss.
Okay, I was asking Nurjan. I'm just checking because some has joined now. Wait, Nurjan, I will ask you. Okay.
Okay.
So Nurjan, I was asking if line BC is parallel to line MN, which vertex is opposite to BC and MN?
Vertex A.
Okay, can you, Nurjan, apply Thales theorem in this figure?
Okay.
Apply.
AB.
Yes.
AB over AM.
Is equal to?
AC over AN.
Is equal to?
BC over MN.
Thank you, Nurjan. This is how we apply Thales theorem in the second figure. Let us directly look at the third figure. In the third figure, I have ABC is a triangle. I have taken point M on AB upwards. I have taken point N on AC also upwards. So as you can see, the two lines CN and BM now are intersecting at A. If the two lines MN and BC are parallel, who's the opposite vertex here, Sarah?
A vertex A.
Okay, can you, Sarah, apply Thales theorem in this figure?
NA over
No.
AC.
No, Sarah, we should start with the vertex facing the two parallel lines. The vertex facing the two parallel lines here is A, right?
Yes.
Yes, so apply Thales theorem, please, Sarah.
AN.
AM
AM.
over,
AB.
yes, is equal to?
Equals AC over AM.
Wait, Sarah, when you apply Thales theorem, if you start the first ratio with AM, you should start the second ratio with AN. Okay, as you can see, Sarah, here I have two triangles now. I have a big triangle ABC and a small triangle AMN, right?
Yes.
So how should we apply Thales theorem? It's very easy. If you start the first ratio, AM over AB is equal to AN over AC is equal to MN over BC. Okay, Sarah?
Yes.
Say it again, please. Apply Thales theorem again.
AM over AB
Is equal to?
AN over
Yes.
AC
Is equal
is
to?
equal to MN over BC.
Thank you. This is how we apply Thales theorem. Any question about this slide, or I can move to an application?
I don't have any questions.
No question.
Okay, now I have
No.
an application here. This application, I want Hadi to solve it. Hadi, are you still with me? Hadi? Mahdi?
Yeah, hello.
Who's this, Mahdi or Hadi? This is Mahdi or Hadi? He's saying hello.
Mahdi.
He said Mahdi.
Okay, Mahdi, are you there? Abbas, can you answer me, please?
Yeah.
Yeah.
Mahdi, are you hearing me or there's a lagging in my voice?
No, everything's good.
Okay. Okay, Mahdi, I want to ask you. Here I have a triangle ABC. We have taken M between AB. We have taken N between AC. How are the two lines MN and BC? How are they?
They're parallel.
Okay, because they are parallel, which theorem can we apply? Yes,
The
Mahdi?
Thales theorem.
Thales theorem. Here, Mahdi, I have given you, as you can
Thales
see.
theorem.
Yes,
Yeah.
Thales theorem you are saying, right?
Yeah.
Okay, as you can see, Mahdi, I have given you the measure of AM and I have given you the measure of AB. Also, I have given you the measure of AN. We should find the measure of AC. Okay, Mahdi?
Yes.
Okay, please apply Thales theorem here. Apply it. What should we say?
It's applying Thales theorem.
Yes.
AM
Yes.
over AB.
AM over AB is equal to?
Equal to AN
Yes.
over AC.
AC is equal to?
MN over BC.
MN over BC, right, Mahdi? Okay. Whom do you have? Do you
Yes.
have the measure of AM?
Yes.
Do you have the measure of AB?
Yes.
Do you have the measure of AN?
Yes.
Do you have the measure of AC?
No.
So which two ratios can we use to find the measure of AC? The first and the second, right?
Yes.
Okay, now when we take the first and the second ratios, which are AM over AB equal AN over AC, here what should we do? We should replace each given one by its measure, okay, Mahdi?
Yes.
Okay, what is the measure of AM that I should replace? AM is given how much?
4 centimeters.
Okay, so I replace AM with 4. What is the measure of AB?
12.
12. So I replace it by 12. Now, what is the measure of AN?
6.
Do we have the measure of AC?
No.
So we leave it AC. No. Now we have 4 over 12 is equal to 6 over AC. In this, if you can see here, we have an equation because we have an equal in between and we have a one unknown, which is AC, right?
Yes.
Okay, what should we do here to solve this equation? What did I tell you? Whenever we have fractions in an equation, what should we do?
Cross multiple.
Yes, thank you, Mahdi. So we cross multiply. We do the cross multiplication here. We multiply 4 by AC, then we multiply 12 by 6, right?
Yes.
Okay, if I multiply 4 by AC, what do I get?
4 AC.
4 AC is equal to 12 times 6 is how much?
122.
No, 72. Okay, so now I have AC is equal to 72. This is an equation. This 72. Is a simple equation. It is equal to 72 over 4, right?
Over 4.
Yes, so if I divide 72 divided by 4, it gives me how much? 72 divided by 4 is 18, okay?
Okay.
So this is how we get the missing measure AC. Did you see how we apply Thales theorem to get the measure of AC, guys?
Yeah.
This is
Yes.
clear. This is how we
Yeah.
apply. This is how we apply Thales
Yes.
theorem in order to get a missing measure given in a triangle. Now let me move to another slide. Okay, if I have this triangle ABC, I have taken M between AB, I have taken N between AC. The two lines MN and BC are parallel. So we can apply Thales theorem here. If I wanted to apply Thales theorem, the ratio will be AM over AB is equal to AN over AC is equal to MN over BC. So this is how we apply Thales theorem. But we can also use two other fractions or ratios from Thales theorem. As you can see, when we apply Thales theorem, it is very necessary or important to choose a vertex and start writing the ratios. I choose the vertex opposite to the parallel lines. So to apply this Thales theorem, I choose A and I start AM over AB is equal to AN over AC is equal to the parallel line MN over the parallel line BC. Here we can also, as I said, use two other ratios taken from Thales theorem. The first ratio is we can use AM over MB is equal to AN over NC. Here, as you can see, I didn't start both ratios by A. I start AM over MB is equal to AN over NC, or we can say it opposite. BM over BA is equal to CN over CA. So this is the basic Thales theorem, and these two ratios can also be used from Thales theorem. I want to apply now an application on what I said. We are given triangle MEF such that EF is parallel to KL. We are given MK is 4 centimeter, LF is 6 centimeter, and KE is 2 centimeter. We should find ML. Now I want to ask Amir to apply Thales theorem here. I want to see if I can get ML from Thales theorem or I can use one of the two ratios I talked about now. Yes, Amir, can you apply Thales theorem in this figure, please?
Okay, so MK is
Yes.
equal MK over ME
Yes.
is equal to ML over MF
Yes, is equal to?
is equal to KL over EF.
The ratio that you said now, Amir, I'm going to write it here down, okay? Let me write it here to see if we can use it to calculate ML, the measure that I need. You said, Amir, if we apply Thales theorem, we will be writing, yes, Amir, say it again,
MK over ME
yes, is equal to
ML over MF.
Wait, is equal to ML
over
over
MF
yes, is equal to ML
over
over
MF
MF is equal
to KL over EF.
Okay, is equal to KL over EF. Let us look at this ratio that you said, Amir, KL over EF. If I looked here, Amir, I want ML.
Yeah.
You can see that we have in one of the ratios, we have ML, right?
Yeah, but we don't have
Let's
the
see.
measurements.
Yes, let's see if I can use any two ratios to calculate ML. Do we have the measure of MK by given?
Yes.
Do we have the measure of ME by given?
No.
Do we have ML? No. Do we have MF? No. So I can't use these two ratios because there are many unknowns in it, right?
Yeah.
Also, I can't use KL over EF because I don't have KL or I don't have EF. So here I can see
Yeah,
that I
true.
cannot calculate ML from Thales theorem. I should use one of the two ratios that I talked about now. If you look, Amir,
Okay.
can you make one of the two ratios?
MK
Yes.
over KE
Yes.
is equal to ML over LF.
Yes, so we can use these ratios to calculate ML. Why? Because we have the measure of MK, we have the measure of KE, we have the measure of LF. The unknown is ML, right?
Yeah.
So we can calculate ML and get the measure, which is 12 centimeter. This is clear? Do you have any question about this, Amir?
No.
Anybody has any question about this, guys?
No,
No.
miss.
No.
No.
Okay.
No.
Of course, as I always say, to get the idea of the lesson, you should reapply these exercises by yourselves again, okay, guys? Because if you didn't apply, you will not get the idea of the lesson. The same exercises you see here, just apply them before start solving the worksheet or the homework, okay?
Okay.
Now, let's move to the converse of Thales theorem. You know that every theorem that we study has a converse. What do we mean by converse? In Thales theorem, we are given Mn parallel to BC. This makes us able to apply Thales theorem. But suppose I gave you a triangle ABC such that M is a point on AB, N is a point on AC in the same order, but I didn't tell you that MN is parallel to BC. You should prove that MN is parallel to BC. Here, if I can prove Thales theorem, if I can find two equal ratios to each other, then the line MN will be parallel to BC. Let us apply an application. If I gave you a triangle ABC, M is taken between AB, N is taken between AC. We have the measure of AB, we have the measure of AC, we have the measure of AM, and we have the measure of AN. We should prove that the line MN is parallel to the line BC. To prove that these two lines are parallel, let us see if we can find two equal ratios. Please, Fadl, I want you to apply Thales theorem in this figure. Can you, Fadl, apply Thales theorem in this figure, please?
Yes.
Okay, Fadl. Please apply Thales theorem here. Try to apply Thales theorem starting from the vertex A, Fadl. Yes?
AM over AB
AM over AB
equal AN over AC
equal, sorry, let me repeat it, is equal to, wait, Fadl. I wanted to write these in front of you because I want you to learn these carefully. AN over AC is equal to what?
equal MN over BC.
Okay, Fadl, I want to ask you a question. Did I say in my question that MN is parallel to BC, or I want to prove it?
لا هي parallel.
No,
Prove.
I want to prove, Fadl, that MN is parallel to BC. Since I need to prove that MN is parallel to BC, then for me till now, these ratios are not equal. If I can prove that any two ratios are equal to each other or they have the same measure, then the lines will be parallel. Let me take the first ratio. Do we have the measure of AM, Fadl, in the given?
Yeah, 3 centimeter.
Yeah, do we have the measure of AB?
Yeah, 6 centimeter.
So I write AM over AB is equal to 3 over 6, then the ratio will be equal to 0.5. Let me move to the second ratio. Do we have the measure of AN?
Yeah, 4 centimeter.
Do we have the measure of AC?
Yeah, 8 centimeter.
So if I replace a n by 4 and a c by 8, I will get a 0.5. Can you see, Fadil, that the two ratios are equal to each other?
Yeah, equal.
Since they are equal, Fadil, then this is by converse of Thales theorem, the two lines MN and BC will become parallel to each other. Okay?
Okay.
Any question about the converse of Thales theorem? Alex, are you getting everything I'm saying?
Yeah, Miss, I think I understand.
So, Alex, to apply Thales theorem, we should have parallel lines. The converse of Thales theorem, if we can prove two of the ratios have the same measure, or they have the same number, or they are equal to each other, then the two lines will be parallel. This is the converse of Thales theorem, okay?
Okay, Miss, thank you.
Now I will be moving to something also applying Thales theorem in it. It is called enlargement and reduction of a figure. By the word enlarging a figure, what do we mean? I will be having, for example, a triangle
Making it bigger?
Yeah, making bigger, yes. Enlarging a figure, making a figure looks bigger. For example, if I have a triangle ABC and I have taken a point O, which is outside the triangle ABC. Now, if by given, all of these are given to you by given. You should not invent anything. All of these are by given. Now, after drawing triangle ABC and taking O outside the triangle ABC, I told you, let's take a point A prime such that OA prime is equal to 2OA. So the measure of OA prime is twice the measure of OA. And I have taken the point B prime twice the measure of OB. So OB prime is twice the measure of OB. Also, I have taken OC prime twice the measure of OC. Here, I want you to see something. This black figure is triangle ABC. This red figure is triangle A prime, B prime, C prime. Can you see that the red triangle is larger than the black triangle? Is it larger than the black triangle?
Yeah.
Yeah, so here I have enlarged the triangle ABC. So triangle A prime, B prime, C prime is the enlargement of a triangle ABC, okay?
Yes.
How did I get this? If I look at triangle ABC, and in this triangle, I have taken a point, O, A prime, B prime, this triangle here. In this triangle, I have two parallel lines, AB and A prime, B prime. If I started from O, then I will say OA prime over OA is equal to OB prime over OB, or the opposite. We can say OA over OA prime is equal to OB over OB prime is equal to AB over A prime B prime. You can apply Thales theorem in the way you like. Then I will get that triangle A prime, B prime, C prime is the enlargement of a triangle ABC. I want to ask you, do you see how did I enlarge each side? OA prime is the enlargement of AO 2 times. OB prime is the enlargement of OB 2 times. OC prime is the enlargement of OC 2 times. So here, the enlargement has a scale factor, which is 2. If I enlarged each length by 3, then the scale factor will be 3. If I enlarge it 5 times, then the scale factor will be 5. Okay?
Okay.
Guys,
Okay.
any
Yeah.
question about this? So this will be given, maybe it will
No.
be given a part in one of the questions, okay? So now I will move to the second one, which is reducing a figure. Reducing a figure is the opposite. I will be having a big triangle and I will be making a small triangle. The big triangle given here is ABC. I have taken a point M on AB such that AM is equal 1 over 3 AB. It is third AB. And I have taken N on AC such that AN is third AC. So here, if I'm taking the third, am I making bigger or smaller?
Smaller.
Can you repeat that, miss?
Smaller.
So am
Smaller.
I enlarging or reducing a figure?
Reducing.
Reducing.
Yeah, by which scale unit am I reducing? By which
1
scale
over
unit?
3.
Yes,
1 over
1
3.
over 3. Yes, this is 1 over 3. I want to tell you something. Whenever we reduce a figure, it is... Any question?
No.
Okay, whenever
No.
we reduce a figure, it's very important to know how to write the ratios from Thales theorem. It's very important to know when reducing a figure, we should start with the small length over the big length. So we start AM over AB is equal to AN over AC is equal to MN over BC. Why? Because AM is smaller than AB. So whenever we write the ratio of reduction, we start with the smaller length over the big length. The small length over the big length. While in enlarging, as you can see, I started the big length over the small length. The big length over the small length, okay? This is how we write a ratio in reduction and enlarging a figure. This was the lesson, which is Thales theorem. What I need from you in this lesson, it is very important to know how to apply Thales theorem in any triangle. To apply it correctly, always you should know who are the parallel lines, and you should choose a vertex opposite to the parallel lines in order to start applying Thales theorem. This is one thing. The other thing is, I have sent to you this week a worksheet applying Thales theorem in many exercises. This worksheet is put on the schedule for Friday, but tomorrow I'm starting to solve the exercises with you on Zoom. So this week we still have 2 periods Zoom mathematics, right? Tomorrow and on Thursday, right, guys?
Yes.
Yeah.
Yes.
So during these 2 periods, we are going to solve the worksheet that I sent on this week, which is week 20. Please, if you can today, start solving exercise 1 and exercise 2, because tomorrow we will be solving these exercises on the Zoom session. Please try to solve these exercises. They are very easy. They are not hard. Just apply Thales theorem in order to solve these exercises, because tomorrow I want you to solve on Zoom. I'm not solving anything. You will be solving the exercises with me on Zoom. So read them today. Try to solve them for tomorrow, okay?
Yeah, okay.
Okay, I'm done.
Okay.
I'm done with this lesson. If you have any question, you can ask me now. Do you have any question, guys?
No.
Any question about Thales theorem
No.
for till now?
No.
No, not really.
Okay. If you don't have any question, Yasmina, I want to ask you, did you do the math semester 1 exam? You didn't send me math semester 1 exam, right? Yasmina? Okay, guys, I want to thank you, and I hope you all join tomorrow, because tomorrow, as I said, I'm not discussing, we are solving exercises, and you will be solving these exercises with me. Thank you guys for joining, and have a nice day. Thank you, and bye-bye.
Bye.
Bye.
Bye,
Thank
miss.
you, miss.
Bye, miss.
Bye, miss. Bye.